Assalamu alaikum. Today the topic of our discussion is descriptive statistics. The learning objectives of this session will be explain why descriptive statistics are crucial in health data analysis, calculate and interpret measures of central tendency and dispersion, understand the properties and role of the normal distribution in clinical research, and the last is construct and interpret graphs to identify patterns in health datasets. So what does descriptive statistic means? Its name shows that it is the description of a data. These are numbers and graphs which shows us the summary of our data. It does not give conclusion of a data, but it helps in generating hypothesis. Like it shows us distribution in time, place, and person. Consider a disease which is in a specific country and in a specific time. And so what will the descriptive statistic tell us about the disease? That it is common in urban area or rural area? Is it occurring in winter season, summer season, or spring season? And in person it will tell us if the disease is more common in older population, younger population, children, male and or female. So the descriptive statistics are like taking a snapshot of your data. It does not test the hypothesis. So there are some measures in descriptive statistics. The first are the measures of central tendency. There are three measures of central tendency: mean, median, and mode. Mean is the average of all the data, and median is the middle value, and mode is the most frequent occurring value in a data. So the mean is the average, but it is affected by the extreme outliers values. So it is not good for the data which have more extreme values. And the median is the middle value. It can be used for those data which have extreme values. And mode is the most frequently occurring values. So we can use the mean in a normally distributed data, and a median for those median and mode for those data which are not normally distributed, but the mode is frequently used for categorical data like nominal data, and median is most usually used for categorical like ordinal data. Example is in analyzing hospital stay duration, the means might suggest 7 days, but if a few patients stayed for 30 days, the median may better reflect the typical stay, because most of the days are 7, but the 30 days for those patients whose values are extreme values, it will change the mean. Like this is a formula of mean. First we have to sum all the values and then divide those by the number of values, that how many numbers are there. Then this is an example of median. You can see that in the first the raw data, the data isn't arranged in a well-shaped manner. In median, first we have to arrange the data in an order. Then we can find the median from the ordered data. And this is the presentation of mode in a data. Like the most occurring value, the three values are group A, group B, and group C. So the group A value is the most occurring value. In this we can also see that in the raw data, here there are 4 blue balls and 4 orange balls. So the most frequent occurring data are 2. So this data will be bimodal. The data can be unimodal, bimodal, and multimodal. And this is the weighted mean, which is used for the outliers data. The arithmetic mean cannot be used for those data which is not normally distributed, but we can modify the mean into various types of means like weighted mean and others, and use it for those data which is not normally distributed. Now there are measures of dispersion. The measures of dispersions are range, variance, standard deviation, and interquartile range. While the central tendency gives a typical value, it does not tell us how spread out the data is. The measure of dispersion tells us about the spread of a data, that how a data is spread, how much variability is there in the data. So what is range? Range is the difference between maximum and minimum value. For example, we have a data which maximum value is 78 and the minimum value is 10. So we have to like 78 minus 10, so the range will be 68. Now variance, average of square deviation from the mean. Measure variability mathematically, but the problem in variance is that it measures the square of a unit. Like if we measure the variance of high blood pressure, so the variance will give us the values in mmHg square. So for that purpose we use standard deviation, which gives us the data in the same unit as the data is. Like we underroot the variance and then the data becomes mmHg, like 160 mmHg. So the unit will be same as the data. Like the square root of variance gives the typical distance of deviations from the mean. And then there is interquartile range, range of a middle 50% of the data. It gives us the middle 50% of the data, which is more robust for outliers. Like this is the interquartile range. You can see here, this box contain, this whisker contain 50% of the middle data. Above this is the 25% highest data, and below this is the 25% lowest data. So variance was standard deviation. Both variance and standard deviation describe spread of the data. Variance is mathematically important but less understandable practically. Standard deviation is preferred in reporting because it is in the same unit. It aligns with the 1 standard deviation, 2 standard deviation, and 3 standard deviation rule of the normal distribution. And clinicians and researchers can easily understand the standard deviation because it is in the same unit. Now, why the dispersion matters? Let us compare two populations with the same mean. HbA1c is 7%, the population standard deviation is 0.5. Most patients are clustered around 7%, showing stable control. As the standard deviation is less, so the data will vary from 6.5 to 7.5. Now in population B, the standard deviation is 2.0. Then here the HbA1c will vary widely because it will vary from 5% to 9%, and in the first population it will vary from 6.5% to 7.5%. Now there are measure of movements. These two are measure of movements, skewness and kurtosis. Skewness shows us the symmetry of a data. Like in this first picture, you can see in the middle graph, you can see the data is symmetrical. So This is a symmetrical data with zero skewness. Now at the left side, this is negative skewness. In the negative skewness, the tail will be longer to the left side, and the mode will be higher than median, and median will be higher than mean. In positive skewness, the tail will be longer to the right side, mean will be greater from median, and median will be greater from mode. Now coming to the kurtosis, kurtosis shows us the spread of data on a central point. There are three types of kurtosis. Like platykurtosis, as you can see the west line, which is more, the data is more spreaded. So this is platykurtosis. Then there is a mesokurtosis. It shows us that the data is somewhat spreaded but not too much. And the third one is leptokurtosis, which shows that the data is too much condensed and pile up on one another. So after these, we should discuss the normal distribution of our data. What is the normal distribution? Normal distribution is a bell-shaped curve where most values cluster around the mean. It is a symmetrical and unimodal. In this type of curve, the mean, median, and mode coincide with one another. And the rule for the normal distribution is at one standard deviation, 68% of the data lies. At the two standard deviation, 95% of the data lies, and at the three standard deviation, 99.7% of the data lies. So why the normal distribution matters in health data? Most statistical methods can be done if the data is normally distributed. For example, t-test, ANOVA, and regression, like parametric test. Confidential confidence intervals and p-values are based on this distribution. If the data are not normally distributed, we may need to apply transformation, or we can transform the data to a normally distributed data by various tests, or we can use the non-parametric tests. These are the tests for normality, like Shapiro-Wilk test, and these three, and we can graphically represent a normal data with these five types of graphs, like histogram, QQ plot, PP plot, box plot, and density plot. We will discuss the codes for R and Python later in this lecture. So, which type of graphs are used in descriptive analysis? In categorical data, we can use bar chart, pie chart, stack bar chart. For quantitative data, we can use histogram, box plot, stem and leaf plot, density plot. In comparison and relations, we can use the graphs like scatter plot and line chart. In chart, for categorical variable, we are using bar and pie chart, and frequency is used for categorical variable. And for continuous variables, we use mean, median, standard deviation, and histogram plus box plot. So what are the properties of these graphs discussed above? Histogram. Histogram is a graph with bars which touch each other. In x-axis there are intervals because it is used for continuous variables. There is no separation between the bars in the data. And on y-axis there is a frequency or density. Its use is to show the distribution of a continuous variable. Good for detecting normality, skewness, outliers. Now the box plot or whisker plot. It shows the median quartile, IQR and outlier. Whisker extend to minimum and maximum. Outlier shown as dots beyond the whisker. We will see them when we will be doing we will be making these graphs on R and Python. So used to compare spread and central tendency, excellent for detecting outliers and compare groups side by side. Bar chart are like histogram, but the bars are separate in these. In the x-axis there are categories, not intervals, and on the y-axis there is frequency and proportion. It is used for categorical data, not continuous data, and it is easy to compare count or proportion between categories. Now the fourth one is pie chart. It is a circle divided into slices. The sum will be equal to 100% or 360 degrees angle. It shows the relative proportion of categories of a variable. Best for small number of categories, not ideal when categories are many differences are small. Scatter plot. Scatter plot. In scatter plot, we see each point as one observation. The x-axis is for independent variable and y-axis is for dependent variable. It is used to examine relationship or correlation between two numeric variables, help to detect linear or non-linear patterns, clusters, or outliers. In line chart, the points connected by lines. The x-axis usually represents time. It is used to display trends or changes over time, common in time series data like monthly sales, patient admissions, etc. This is a short summary of the graphs. Like histogram is used for histogram, box plot, and density plot is used for continuous data. Then bar plot, pie chart is used for categorical data. Line chart is used for time series, and scatter plot for two continuous data. So, what are the discussion questions in descriptive analysis? In oncology trials, why is median survival reported more often than mean survival? In this question, they are asking that why are we using median instead of mean? So this is because that the survival for the cancer patients, as this is oncology trial for the cancer patient, is different from one another. Some patients live longer and some patients die earlier. So there are many outliers data. So we will use median for this data. The second one is how does standard deviation differ from IQR in summarizing data set. Actually, this standard deviation is sensitive to extreme values, and the IQR focuses on middle 50% of the values. It does not take into account the upper 25% and the lower 25%, so it is not affected by the extreme value. The third question is, can you think of a health variable that does not follow a normal distribution? So the examples are length of hospital stay. It may be different for different patients, medical costs, and time to recurrence of the disease. Now we will be practically doing these things on R and Python. These are slides, but if you do it practically, it will be more better. So this is R. We will be using a data. So in this R, first we have to load our library. If we don't have the libraries, then first we have to install it. We can install it from here, like the packages are written. Here we will click on the install, and whichever library we need, we will just click it here and then click on the install, so the library will be installed. Or we can install it by this code, install packages, and then we will write the library code. Like if I want to install this library, and then I will run this code by control enter, and it will be installed. But I have already installed it, so I am not going to do it. I am just going to load my libraries. So first I have loaded the libraries which I need for the descriptive analysis. Libraries are loaded. Now I will import my dataset as it is in the text file. So I am selecting the text reader. This is my data. Okay, the data is loaded and you can see it in here. Now I will just change the name of the data, and then I will run the code so that now this is my data and you can see it in here. You can also change the names of the columns, like the code for the changing the column names is call names. Then for which column name, for which data you are changing the column name, this will be the data name. And this then then these will be the column names you assign to the data columns. Like the column name here is 10,000 25 5 1 dot 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 3. So I can change these into these: age, tumor size, ID, whichever I want. So let's coming to the central tendency. So if we want to find the mean of a data, we will apply this code like mean, then there will be data and for which variable we want. So this will separate the data from the variable, and this is our variable name. If I enter this, you can see it in here that our mean for the column 1.33 has been calculated. Similarly for the median, this is the median, this is the formula. Now this is our data name. Then this will tell us that in this data, this is our column for which I want to calculate the median. So if I enter this, the median is 1. And for mode, this is the code for mode. Here you have to change this area, like this is our data name. This tells us that I am entering a column of this data, and this is the column name. So if I enter it, our mode is 1 here. Similarly, we can calculate variance, like variance for the column number 5 in breast cancer is 7.993. Similarly, the formula for standard deviation is ST, and range and interquartile range, the formulas are these. You can see that the range is 1 to 10 and the IQR is 2. So the main part in this code are you have to know where you should be editing. Like we can create code by AI. Here the code preparation is not a problem, but you have to know that where I have to change the name of my data or my column, where I have to put column which can give the results according to my data. Like for standard deviation, the AI will give you a code like this. But in this you have to know that this is my data name, and if I want to calculate standard deviation for column number 5, then I have to enter this sign and then the column name. Then it will work. If I remove the column name and do this, there will be an error because this is the data. And for the whole data, we have to find the standard deviation for a same variable, not for our variable at once. Now these are the codes for Skewness and Kurtosis. We will be sharing this code with you guys, and you can view the codes in the drive file where the link will be present. So this is again the Skewness code, but this is our data and this is our column name, and this is the sign which will show us which tells us that this column belongs to this data. So you can see that the skewness is 0.5 and the kurtosis is 2.99. Now if I want to make a frequency, I can enter these codes like table, and again here you should know that this is my data name and this is the column name. When I enter this code, these are the frequencies of the values occurring in my data in column number 5, and these are the proportion of the data occurring in my data in column number 1.1.4. Now let's create graphs for the descriptive analysis. First we have to load the library ggplot2. Then from here, this is the code for histogram. First it tells us that we are creating a histogram, so the code is hist, then bracket, and then there is our data, for which column you are made, what will be the name of the column, what will be on the x-axis, what will be the color of the graphs, and what will be the border looks like. So this is a code for histogram. If we enter it, you can see that on the x-axis, this is the x lab. It tells us on the x-axis which column do you want. So this is column number 5, or you can change this name to suppose frequency. Now it will change the 5 into frequency. So this is the main name of the graph. So histogram of age, you can change this, like if I am changing only it to histogram, then I will just enter it and it will change into histogram. The color is light blue, you can see the graph color, and the border is black here. Now if you are creating a box plot, this is the code, this is the data again, and this is the column name, this is the name of the plot. Like in here, this is histogram and it will be box plot. and what will be the color. So if I run the code, you can see that the name is box plot, the color is light green, and it is for the column number 5. Now these are bar plots. Again, data in column, what will be the color of the bars, and what will be the bar name. I enter it, you can see the orange color. Similarly, for pie chart, this is the data and column name. This will be the name of the chart, and these are the colors. You can also increase the colors whatever you like if I have 1 2 3 10, then I can add 10 colors here and all the colors will be different. Let me show you. Now there are 3 colors and I can also extend it to other. So okay, now coming to the scatter plot, you can create all these codes with AI. Also these will be given here in the PPT, which will be shared. Like these are the codes, then these are the Python codes, these are the codes for dispersion, variance, these are for distribution, frequency, histogram, box plot, bar chart, and these codes are for both R and Python. Pie chart, scatter plot, and codes for normality test. Okay. Now coming to the scatter chart, again this is the data and this is the column. Then this is the data and this is the column. And in scatter plot we will be using two variables. This is the name of the plot. What will you like to enter on XLab? Like this is frequency and this is proportion. Suppose so you can see here that the data is spread across the scatter plot. Okay, now these are the tests for normality. So the Shikaro test I can, this is the main code and then this is the data and this is the color. So if I enter it, it will give us the result like p-value is 2.2 for minus 16. Similarly for Kolmogorov Smirnov test, you can use this code and ignore this warning, it has already given us the results. And this is the histogram for normality. Like you can see that this data is not normally distributed. And this is the curve. In this you can also see that the data is not normally distributed in the other codes. Now let us go to the Python for these. You can open Python from CMD. First you have to install it. Pip install notebook. This will install your Python. I have already installed it. Then you will open it with this code Jupyter notebook. If it didn't enter your code Jupyter notebook, then you can use this code Python -n notebook. So this code will work and it will open your Jupyter notebook. This is Jupyter Notebook. I have already opened it. So here you will open the Python kernel. When it's open, you can use the codes. Okay, now this is our Python Jupyter. Import files. First of all, we have to import our libraries. In the Jupyter Notebook, the advantage is that we can run all the codes at the same time. Since I have run two codes at the same time, and ideally, the problem is with that we can run only one code in the ideally. So I am preferring Jupyter over ideally. Now, here is my data. I can just copy it. As you can see, you can get the code from these areas like ChatGPT and okay. Now the code is run and my data is being loaded into the Jupyter. Now I have just copy the codes and run it here. These are the codes for Python. Now for calculation of mean, this is the code. Here it means that we have to give the column name. If the column name in this data is 51112, so I will give column name of 5 and just run it. Okay, there is an error. It's okay. We can change the code according to our needs through the ChatGPT. Like this is the code for bar chart. I don't have time to correct the code through the chat GPT. I have just I will just show you the correct code that how it can be done. This is our data, this is our column, and these are our code. So this will be our title, this will be our x-lay, this will be our y-axis name, and this will show us the graph. Okay, there. Okay, now this is our graph. You can see here that the bar plot is being made. Now coming to our box plot in the Python, this is the code for box plot. And if we use this code, like this is our data and this is our column, this will be our title, this is our xlab. So if we run this code, okay, we haven't imported a library matplotlib is what is the name of this library? This is our library. First we have to import our library, otherwise our codes will not work. So you can see after I have imported the library, there is no problem with the code. The code has run. Similarly, you can use all these codes of the Python, and if there is a problem coming, you can just make your code, copy into the chat GPT, copy your data into chat GPT and tell the chat GPT to correct this code according to my data. And it will help you correct the code to some level, but then if there is a need of editing, then you have to know that where we need the editing, like where is our data name, where should we add the column name, where should we add other things, like if we want to change the name. You just have to know the basics of R in Python for it. If you don't know the basics of R in Python, then you can't be able to use these codes, because these codes are for my data, and you can use these codes if, like this is a Python code, this is my data name, so your data name may be different from mine. This is my column name, so your column name may be different. Okay, and here I want my chart name to be pie chart of gender. You may want your pie chart name is different. I want my X label is, here I can write as gender. So I want the colors as pink and blue. So you have to need to know the basics of R and Python for it. It's not very difficult. You can easily learn it in a month. Now this is our scatter plot. So this is my data name, this is column name, this is again the data name, this is again the column name. So your data may be different. Your data name may be, my name is df, and yours may be data1, data2 or other. So my column name is 1, yours may be age, gender. Okay, coming to the conclusion, descriptive statistics summarizes large health data set into meaningful numbers and graphs. The central tendencies are mean, median, and mode, which capture the typical values, and dispersion shows us the variability of the data by range, variance, standard deviation, and IQR. Normal distribution, which is the foundation of many statistical methods, and graphs, which show us the summary of our data. Always visualize first. Choose resistant statistics or skewed data, like median and IQR. Report sample size and missingness. Document code and version. Use survey weights when provided, and remember, the normal distribution is a tool. It is not a truth. And thank you for this session. We will be meeting inshallah in the next session.